Right, good evening, afternoon, let's call it afternoon. It's not quite, well, it's late afternoon. Early evening, whatever. Hello everyone, those that are joining us, and welcome back to another live stream where we're taking a look at, again, the BQ-Hurakan, which we actually just did yesterday evening. I think, wasn't it? Yeah, that was then. So we just kind of did an unboxing, we assembled it, took a look at the electronics and stuff, so you want to check out the other video that I did on that if you want to see that stuff. And we did the first print. It came out okay, but it definitely needed some improvements. But there's a bunch of tuning we can do with this printer and using Klipper. So I wanted to try and run through some of those things to test them out. See how fast we can go, see how crazy things can get, see what happens. Good evening, good evening, good evening. Good evening, Lars. Good to have you here. So, the plan is basically, first we're going to do a flow rate test. It's not like a super advanced flow rate test, but we should get a reasonable estimate for somewhere around a maximum flow rate with PLA. And then we'll do, I think, a maximum, well, that will give us somewhere in the region of a maximum speed. And then we can use that speed or somewhere, it'll give us a guide for then doing maximum acceleration and or speed. We don't have long today, maybe like an hour will take us to 5:45, so maybe an hour and a half, something like that. So we've got to get a wiggle on. Use that speed. Oh dear, try not to listen to my own stream at the same time. Oh dear. Oh dear, chat's not showing up properly. Okay, great, sure. So, first thing we need to do is turn it all on and get this other filament out. So, we're not going to do flow rate testing with the fancy filament. I'm just going to put in this single color yellow. It's useful because we can see it easily. And I don't want to use something that I don't have very much of. So we're just going to preheat, take the filament out, put a new one in, and then we'll basically try some different flow rates and see where it starts to skip and or jam. Hopefully we'll try and do another print at the end today, but as I said, we're pretty shortish of time. Depends how we get on. If we can do another little buggy, I think that'd be quite a good thing to compare. I pulled a lot of the strings off of this one, so it looks a little bit better than it did just right off the printer. But yeah, that's the plan. It's taking 45 seconds. I don't like this 45 seconds to turn on business, but it is what it is, I guess. Okay, it's turned on. So for anyone that didn't see yesterday, because we're now running Klipper, we get a super easy web interface which we can access by going to here, and if we remember to plug in the network cable, then it will work. You can set up Wi-Fi, I just haven't. Doopy doopy doo. Here we go. Main sale. Evening, Ronnie. Good evening, good evening, good evening, good evening. Oh, did I forget to set it? I think I forgot to set it to low latency again. Oh, you have to set it in a different place to where you set everything else. Why? I have no idea. Anyway, sorry about that. So, let's get the preheat. And then we're basically just going to be using manual controls for the extruder, extruding a length of filament at a given flow rate. It'll even give us an estimate down here. I'm pretty sure this is dynamic. That'll help us find out how fast we can push filament through this hot end. I'm not expecting a lot. I think this hot end is probably the key limitation on this particular machine, but everything has a limitation, so it's just about finding it, understanding it, and then potentially improving it if you feel like it. The guide we're going to be running through is basically Andrew Ellis's print tuning guide. So this is designed primarily for Voron, but it is very generic, sort of. Lots of stuff driven by macros and things. And it's based on using Klipper, so much of this guide is specific to printers running Klipper. So now that we're using Klipper, oh, wrong page, it should be pretty useful. I should mention this printer was provided to me by BQ/BQ Tech, kind of the same thing, but not entirely. But anyway, they provided the printer for purposes of me doing some videos, well, a video, but I fancied doing this tuning one. I thought it was a pretty fun thing to do. I am aware, and BQ are aware as well, that there have been troubles with the CB1. They've had a bit of a rocky start in terms of getting Wi-Fi and wired connections working smoothly and consistently. So it does depend a little bit on what version you're running. As far as I understand, a few weeks ago they did solve it with a firmware that will do both Wi-Fi and Ethernet as you'd expect. So it should all be fine. If you just Google Andrew Ellis print tuning, you should find it. I can put it in the I just remembered I forgot to credit E3D's model in my description yesterday, so I shall endeavour to do that. So let's grab this filament out of here. There's probably an unload procedure, but I prefer the just pull it out method. That could be there. Right, have some bright yellow. This guide is like 3D printing, but it is a good guide. It is very good. This is the thing that I've had most trouble with this printer, I think, is getting the blooming filament into the place it needs to go. I'm not sure that's quite inserted. Oh, I think that's pushed it past. Yeah. Okie dokie. So I am going to hope. Oh, I shouldn't have that. So let's home the printer and we'll get it to a kind of appropriate place. Clean this stuff off the bed, don't need that around. Maybe bring this a little bit closer to the camera. 'tis a good guide. So, hopefully, so we're at 215C, we don't really need the bed heated, let's turn that off. And about no pressure advance, filament length, we'll do 50 millimeters of length. So you can see extrusion feed rate of 1 gives a flow rate of 2.4. So we're just going to do this at increasing speeds and see where we get to. It's going to be very slow to begin with because it takes 50 seconds to do 50 millimeters of filament at 1 millimeter per second. But it gives us an indication of making sure that things are working slowly as well as working quickly. So we'll probably do it 1, 2, 4, 6 and 8 maybe. Looks pretty smooth. Oh. I think that's done. Yeah, that's stopped moving. Where's me? So 1 works fine. Let's try 2. 2 is 4.8. So this is already quite a big step up. We can also then convert the flow rate to a printing speed. This is all looking pretty good. We get a nice clean little spiral. That's fine. 2 works okay, so we'll double it again to 4. I don't know why I have to press enter to add it. So 9.6. That's looking reasonably clean as well. You can actually like do 2 in a row. Oh no, oh, I accidentally pressed retract. You nitwit. Extrude. So this is 4 again. 4 passed. So we'll probably go maybe 6, 8, 10. This is quite quick. We'll start to see some bulging and a kind of dye swell effect. Oh, that's done already. So we're verging on the edge of what's capable with 6. Eight's probably going to be a bit of a push. 8. There we go, you can hear that as well. You can see it in the sample very clearly, so let me show you that. You can probably see it's kind of big and fat. So like, see the difference there? This, not good, all fat, thick, weird. And if you stretch it, you'll find it goes into like, yeah, it goes weird. But this is obviously good. Thin, about the same as nozzle diameter. This, fatter than the nozzle diameter. So we're in between those two values. Let's just try, so 8 is a fail. I think 6 is probably about the limit, but we'll give 7 a go. Yeah, 7, it works for a little bit because there's, I mean, that's quite a dynamic property of the flow, but it doesn't work sustainably. You can see probably some fat bits. It started off kind of slim, but definitely ended up pretty fat. So 7 I'm going to say as a fail. Maybe 5.5 is maybe a pretty good sweet spot. Because bear in mind, we want to be able to do this consistently, not just for a little bit. That looks pretty reasonable, looks pretty consistent. You can see how it kind of all spirals nicely. Consistent looking diameter means good flow. Very nice. So I'm going to say 5.5 is probably the best. 6 was a little bit iffy. So 5.5 millimeters cubed per second. Now that we know that, that's going to be like the fastest that the printer can move while printing, because if it's moving faster than this while printing, it's not going to be able to extrude that amount of plastic. But this is not a printing speed, this is just a flow rate. So that's the amount of plastic. So we want to know if we're doing like a 0.2 layer height with this 0.4 nozzle, how much spread, what's the equivalent speed. And to do that, have a calculator. So I know it's not 5 millimeters cubed per second, is it? It was 5.5 millimeters of filament per second, which is 13.2. It's on the screen. Let me show you. So here, this equates to this. I don't know why it says estimated extrusion 219 millimeters. I guess that's the length of the extruded filament rather than the filament input. So it changes from a 50 millimeter length to a 220 millimeter length by going through the nozzle. So 13.2. It's actually not too bad, it's reasonably good. Oh, my computer's just run out of disk space. That's going to be problematic. Oh dear. 41 megabytes remaining. Oh dear. Hang on while I try and deal with that. Otherwise it might all crash. I don't know why it's recorded such an enormous file. Okay, so, as I was saying, the next thing is to then convert our extrusion rate into a speed. So, just finding my calculator. Printing speed. Here we go. So it's just a little spreadsheet. So based on these properties, converts one to t'other. So this, printing speed. Or can we do flow rate? Yeah. Based on flow rate. Got this printing speed. Oh no, hang on. We might have to do it a bit backwards. We don't want this basically going over 5.5. So it's about 76, 77-ish. 77 is 5.5 millimeters cubed per second. So our maximum printing speed is 77. Which is not like massively fast, but it's also not super fast. Oh, looks like I did it backwards down here. So we could have put in a 5.5 in here. 77. Cool. So now we know that, we can try some other things. So that's value 1. Maximum print speed, 77. So we're not going to go through like every element of this guide. Oh yeah, Nora. So yeah, sorry, I've confused it, haven't I? Oh, wrong calculator. Oop. Oh, did I close the other one? The 5.5 is the filament speed, isn't it? 13.2 is the flow rate, which seems very high now. Huh? What? This guy. I'm not sure we'll manage to sustain 13.2. So 13.2 would be 185. Sorry, ballsed it up, didn't I? Which is really fast. I don't think we're... The rest of the printer might not keep up with that. Hello, it's 247 Printing. Right. So now we move on to... That's far right. I'm not going to do mode currents. So I think for this it prefers to have linear, not linear advance, input shaping. So we need this macro. Hang on, let me just read it first and remind myself. Yeah, okay. Yeah, okay. So was this pressure advance, extrusion multiplier, pressure advance, cooling, retraction, infill, tuning. I think the we should probably do the input shaping first. I can't remember. Does it say? You may also get higher maximum accelerations using input shaper and may want to retune your max accelerations after tuning input shaper. So we'll go and do input shaper now. Hello, Alexander. Is the plan to print a speedboat? The plan for today might be a little bit stunted because I'll run out of time. I have to do other things this evening. But I might do some more stream stuff with this printer just because it's fun playing with Klipper on a penciling a printer. Right. So although there's going to be, oh, this is the page I was already on. I believe the guide here, auto, yeah, we go, ADXL 345 resonance compensation calibration. Oh, you can't see it because the, so this is the manual, the online manual for the Hurakan. So instead of following the Klipper guide, we'll follow this one. So this is the accelerometer that comes with it. It looks like the mounting is going to be a little bit squiff. Yeah, okay. This is slightly weird, but sure. So one thing we should do, I'm just going to turn off the printer. Because it's running a compute module, which is a CPU rather than just a like instant off microcontroller, and it's running an SD card, which can get corrupted, you should turn it off before you do that. So do the shutdown, wait for it to shut down, and then turn it off. There we go. Boom. So let's get it's a bit weird why they've invested all the time with loads of custom parts for this printer and then just got this ADXL module that doesn't really fit. So this is how they want you to have it, and you want to have it as square as you can. I mean, it's going to be a little bit wobbly. Actually, it's not too bad. Okie dokie. Install that in there. Adjust the position and fix it with a screw. Connect the cable. This would be one thing that's quite easy to get wrong if you're wiring it yourself, but with a pre-made cable, hopefully. If I can find which way around this cable goes, it should be quite easy. Make sure this is straight. And we route this to the back. Oh, blue, poor cable. Oh, I've just had the camera pointing at the wrong thing half the time, haven't I? This will go in down here. Hello, peoples. Here we go. So all the stuff that you need to do this on this printer is already installed, so you don't have to do too much. You just kind of go ahead and do the things that you do. Oh, sorry, switching around. So obviously we've got to turn it back on and wait the 45 seconds for it to actually turn on. I can potentially try downloading the plot. Why, have you lost the plot? Yeah, but I don't know if that pun will translate. Come on, come on, come on. Here we go. Come on, come on, come on. There we go. Right. So the command we're after is this. Hopefully it'll just copy. No, it's not going to work, is it? I don't know why it's... Oh yeah, because we have to put it in two different places, don't we? Of course. We have to move it. So we want the console. We want shaper underscore calibrate axis equals X. Oh, we have to hand it first. Oops. It should be possible to download if they've done the things that are needed to do that. We shall find out. I think we're going to move it up just a touch. Maybe not quite that far. That's about good. So I'm just going to run this command, but I'll give you the wide angle so you can see the whole thing, that's the close up. So what it's going to do is start vibrating. You can see it wibbly wobbly wibbly wobbly, and eventually you'll stop seeing wobbling because it's going at quite a high frequency at a very small distance. And you can see the console here showing the testing frequencies that it runs through, and the accelerometer is measuring the acceleration at each of those frequencies. And if I remember correctly, it goes up to 133 Hertz. Ooh, that's a lot of vibration. You probably can't hear it, it's quite low hum, 49, 50 Hertz, the whole desk is shaking. It's amazing what stepper drivers can do, they're absolutely mental. Stepper motors, I mean. Yeah, so the CSV obviously is like the data, and that's enough for it to like automatically determine. So it's possible that BQ have not implemented the extra plotting graph stuff, because it's not really needed for most people now that it's to the point that everyone's kind of comfortable using it. It's useful for like diagnostics, troubleshooting, and just more information, but I can fully understand why they wouldn't necessarily bother. So, I mean, at this point, you can't see any movement, but it is moving very quickly. I keep going to the wrong blooming screens today, all over the place. $29, 130, 131, 32, 133. And stopped. So then it does a little bit of calculation-y thing. Wait for calculations. It's doing lots of waiting. While it's doing that, I want to find why can't I? Oh, it's a different page. We probably should do this first, and not test resonances. What's the test command? Yeah, accelerometer query. That would be worth doing, I think, first. Here we go. Temp calibration CSV file. Recommended shaper MCV 588 to avoid much smoothing with 300 PI. Suggested max acceleration less than 8400. Calculations. So I'm going to do save config there. I'll save the first lot. In your opinion, the graphs are vital because a very messy graph can give falsely high acceleration recommendations. Which I get, like it's not perfect, but I don't think if you imagine everyone running this, I think there's a certain level of understanding that you need in order to get to that point. So now we're going to home again. And I think it wants us to use like one of these bed screws at the back, which is pretty sus, but I did check out the manual before, and I'm pretty sure this is what it was saying. Take out the screw. Oh dear, this is weird. Which one? This one. Probably doesn't matter. It will matter the orientation that you install it though. Okie dokie. So same wiring, and then shape of calibrate axis equals Y. Again, you can probably just about see the bed moving, but this is going to be absolutely mental. When it finds the resonance of the desk at like 40 something hertz. Oh, it's craziness. I don't know why this is so entertaining. $45, $46, $47. Oh, look at it go because of the springs. You can see it like tilting. Obviously, it's to do with the capture rate of the camera as well. $96, $97. For those that were here yesterday, by the way, can you hear me better today? Is the microphone, oh, it's probably a bit low, but it was sounding a bit quiet, I think, yesterday. Hopefully it sounds okay today. Also, do you notice any difference in the lighting? Getting there, 129, 30, 32, 133. Oh yeah, because we did a save command after the x-axis, it will have disabled input shaper to start this. A lot louder in a good way, or a lot louder in not a good way. I'm not peaking. Hopefully it's not peaking, just a little bit louder. So it's doing these calculations again. I think this will probably be quite a noisy measurement because of the springs and the wobbliness. MZV is typically what we end up using. Right, and we'll do a save config. Blooming hell, it's 6:30 already. That was quick. So, should be down here. So these are the values we have. These are the values that were measured previously. So these were commented out in the firmware when I got it from Big Tree Tech. These are the ones that I've just measured myself. And we should go and have a look at the graphs if we can find them. Hopefully we can find them. So let's see if I can remember how to do this. No, not that. Right, we're going... Oh, do we have to generate them? I don't know. Measuring resonances, test resonances, X. Max moving. Above suggested shape images, but what if you get less smoothing? Oh yeah, you guys are on massive lag today. So you'll probably watch me doing something wrong for 30 seconds before I actually change. Should calibrate. This is on the CFV. Recalibration. Offline processing. Plot. I think this might work. If we go to, I'm going to use WinSCP, and I'm going to create a new session, do a new site. This is our IP address of the printer, and I believe it's BQ. I think they're both just BQ like this. Yeah, so the directories are a different name here. But that's hopefully not going to be a problem. Let's find out. We can open a console window, I believe. Yeah, something telling me this doesn't look right. Where is it? Temp. Yeah, so these are the two CSV data. It's these that we want to plot. But I've forgotten how to plot it. Where is it? Aha, is this? That looks like the same thing. I mean, this looks like the thing. Let's try that and see if it does a thing. I think this wants to be calibration data. underscore x underscore that. Anyway, that'll do, I think. But this is going to do both of them, which I don't know if we want to do. We want to do just one, don't we? Underscore x underscore 20221026. We might just do a separate SSH session. It's going to be easier, I think. So we do SSH BQ at 192.168.1.129. Password BQ. What? Okay, I think I run that command too early. Let's try again. No. What? I'm not sure this is going to work unless somebody else understands what's going on. I don't know how to rename default users. I think we're just going to have to bypass that image for today. If someone wants to like send me some stuff on Discord how we can do that, then I can do that on maybe another stream. We'll look at that. But today we'll have to be satisfied with the fact that we do have values. We just can't necessarily validate them, but they look kind of reasonable. What we don't have is the acceleration values, which we do also kind of need. But I remember, is it still in the console? Here we go. So the Y will be the lowest maximum acceleration because it's the heavier of the two axes, and you have to have them both the same in Klipper. So if we, I think it was MZV that it recommended. Yeah, MZV 32.6. So if we look down here for MZV, you can see max acceleration less than or equal to 3100. So I'm going to go 3000 as our machine limit for acceleration. It is not in there, it's in here, I think. I think it's on the printer. And it's already on 3000. Maybe we'll go to 3100. Pushing the limits. Okay, now we can go back to the extra fun bits. So, yeah, we'll try get, I'll put on down, I'll make a note for input shaper graphs. Unless somebody can send me stuff in Discord like straight away. So first we need this macro. What we're going to do, I think I already have it. Oops. No, maybe not. Okay. So we need this macro. So this opens up here. I think what we do. Oh no, wrong one. Review raw, and then we save as. This will save it as a file we downloaded, and we'll just save it as testspeed.cfg. You don't want the text bit at the end. And then we need to go over to here, upload a file, and select the file. And then refresh that, and we should find it. Here it is. Double check to make sure it looks appropriate. That looks like the right thing. And we got. Did OBS just cut out there? Is that okay for everyone? So that's, we need to add into here and include. So a section called include like this basically allows you to just add other files into your firmware configuration. It's a way to just kind of manage things rather than just having a massive single text file. Okay, cool. Live stream's still working. Yeah, it just gave me some weird warnings. It's like fixed and broken and fixed, and then it went away. So now we've got that macro installed, we do have to do a quick restart. Let's stop clicking around too many tabs. Let's close some of these. Don't need that, don't need that, don't need that. So we've got a max velocity, fully heat soak. Ideal the test should be run at the chamber temperature is your actual printing conditions. I mean, this is the chamber condition for my printing. It's just open in the room, so we won't do much of a preheat. Yeah, to be honest, I actually don't really like the way that they have their firmware set up here. I might try and reconfigure it and suggest it to them that they change it, because it's, for new users especially, it's going to be pretty confusing. I prefer, as you say, one for macros, one for like printer configuration, maybe one for like specific control board configuration if they really feel like they want to do that. But like printer, in my mind, for a new user, just wants to have things like stepper motors and the maximum speed, max acceleration, and maybe like Z offset and probe and stuff like that. Stuff that you might expect a user to change should be in there. Macros, most people will just leave fixed and all that kind of stuff. Anywho, we now have a new command in our macros, which we'll see here, called test speed, and requires some inputs. So we're going to run the test speed macro using the instructions below with increasing accelerations until you experience skipping. Start with a small number of iterations. Test speed acceleration 5,000 iterations equals 2. Probably really small and you probably can't read the text. Sorry about that. Once you experience skipping, go back a little bit. Once you've found a rough maximum, run the test again with a larger number of iterations. If you experience skipping during extended testing, lower it back down. Use a slightly lower value than your results. Save your new maximum to max acceleration. Use the acceleration graphing calculator at the bottom of the page to find the theoretical maximum speed for your acceleration or print area. Okay. So we need sed command. We'll try, just copy this one. So hopefully this is going to work on this printer. It should work just fine. Paste that in and we'll start low, like really low. And we just run this. So what's going to be the best way for me to show this? Maybe like so. Actually, what we want to do, let's just go to the console one. That's going to be better. Makes sense. We send this, and we hope for the best. We might have to home first. See, smart macro, is doing the homing for us because we're too lazy to do it ourselves. So this is the test procedure. It just kind of draws crosses across the bed, then goes around it, does a weird little jiggly in the middle. Probably don't need to leave the accelerometer on the bed. Yeah, the little probe is super duper loud. I think it's when it retracts back into the housing and it's just like smacking into the plastic enclosure. It just needs like a tiny bit of silicone rubber. I don't know why it does this slow move across the bed. So that's what that process looks like. So I think one of these is before and one of these is after. I forget how this works. Let's just double check. Compare the numbers for X and Y steppers for the first and second homing. Here and here. Represent the microstep position. Ensure that difference between those numbers has not exceeded a full step. I'm running microsteps of 32. I would ensure that the values have not changed by more than 32. So we'll double check our microsteps in the firmware. Probably in here. Step X, microsteps 16. X and Y both 16. So as long as this is not changed by 16, that one's changed by 1, and that one's changed by 0. So 1,000, we're all good. Right, let's up it a bit. Let's go to 3,000. It is on springs, that's correct. So it is going to be a little bit on the wobbly side. Yeah, I was wondering how well it would work, because obviously drawing across on XY, like that makes sense. But maybe it's not going to work so well when it's just doing two independent axes. I don't know. I'm not sure what this bit is. This really slow move across the bed. Oh, what was it configured for? Was it stealth chop? Wing speed, max position length. How did you know it was spread cycle versus stealth chop? I thought it normally says. Am I missing something? So again, exactly the same. So that's all good. Let's go, and we'll double it. Oh, and TMC configuration, of course, is. Sense resistor. Isn't sense resistor for senseless homing? But they've not utilised senseless homing. They have utilised sensors. Yeah, I mean, it explains why it's really quiet. So we might look at doing that as well. I could say, Alex, I'd test it, but I don't want to do it now, just in case it's just going to like crash something crazy. So that worked fine. That 6,000 was actually fine. Oh, not a million. We'll just double it each time. We don't have long left. We're not going to do as much as, well, I don't think we've managed to do as much as I was hoping today. This is less entertaining than it was on the Core XY. I think it's looking to move to that position, thinking it's over here or something. What's our speed at? $180. It is quite slow. Well, we've just managed that. So that was only 180 millimeters a second, bear in mind, not 300. We could maybe, I mean, in my mind, if we're using input shaper, we don't want to go faster than the hot end can manage. The speed is set to 180, and that's the maximum speed that we found. So I'm going to stick it with 180 because we can't print at 300 anyway. I think that makes sense, right? So this is going to be now 20k acceleration. That's pretty good for a bed slinger. It's set to 185 and we can print at 180. Set to 180, we can print at 185. So for actual printing speed, we should be fine. The hot end is not going to go any more than that at absolute max chat. So. Ooh, I think we might have had a little skippy there. Just seem to be those little movements that causes problems. We'll see. So we're looking for a 16, oh, after it does this really long, slow move. You want to be able to travel faster than you can print. This is true, but we don't need input shaping for our movement. Yeah, I can put, so the only reason I was going to change it now is so that we're doing these without having to have an extra setting for the speed and all this kind of stuff. I just wanted to know what speed I was testing this at. That was, but yeah, for travel we can probably go faster. 20k. So it wasn't skipping. I've only got like 15 minutes, so yeah, FYI. We're not going to be doing a print, that's for sure. But hopefully we'll find a limit here. I would believe that the acceleration also counts when traveling without extruding. What do you mean by it counts? It counts on printing speed, but we don't, the point is, it doesn't need to be precise. If we get vibration during travel, that's not going to be a problem for the print quality. Whereas if we're trying to do a nice outer perimeter and we get ghosting, that's what we want to solve with input shaping. Ooh. This is really close, I think. Excuse me. Oh, that is skipped. So you can see the difference between both X and Y there. 722 to 787 is much more than 16. So we have definitely skipped. So that was 30k though, up from what, 20k last time. So let's split the difference. Try 25. Maybe 20k is going to be about our limit. We'll have another couple of runs, see where we get to. Oops, a daisy. And then I get to go do other things. Like eat some food. I think that sound you can maybe hear is the inertia of the wheels, maybe? I'm not sure. I think it's slipping of the wheels on the rail. because the belt is providing more force than the wheel. I mean, the force is not going through the wheels, but they've got to spin up in order to move. I don't know. Maybe. Just a thought. What did we get to? 25k looks all right. Let's try 27,500. It feels a little bit less dramatic than the like 90k that we got on the Voron. What accel to decel are you using? This is a good question. I should have checked. Is that... It's probably not defined, in which case it's half of the acceleration, isn't it? I'm pretty sure it goes in here, right? Max acceleration to deceleration is set to half the acceleration. I think I might have heard it again. Where are we going to get to? Where are we going to get to? I don't understand why it's doing this. Sorry guys, if you're commenting on what I'm doing, and as you see it on screen, I've already done it like 30 seconds ago, so I can't, it's very difficult for me to respond to things as you say them. That's within 2 and that's within 1, so that's weird. It must have only just failed at 30k. I mean, we're probably going to want to settle maybe at 25, 26 anyway, because we don't want to sit right up against the limit. That's just going to cause problems. What I'm going to try actually at the end of this stream, if I remember, hopefully I will, because it's only like 10 minutes away. I'm going to try and modify the setting to change it to ultra low latency by ending the stream, changing the setting and restarting the stream, and it should just come back into the same page, but I don't know, so I want to do a test. Obviously I don't want to do that at the beginning of the live stream because everyone just disappears and goes, oh, I can't be bothered if it's not going to work. So I'm going to try that at the end of the live stream. You don't have to stick around and watch. That sounded like a little skipperoonie. Come on. I want to know the results. So that passed as well. That was 29k. It was 30k we failed on, yeah. Okay, so I'm going to try a longer one at 28k. I think that's maybe where I'm going to settle if 28k works. 10 is not that many. I mean, the suggestion is something like 50, but I'm not going to do that on a live stream while we sit here and literally watch it. If I was you, I'd set up the 50, go and do something else for a little bit and leave it to do it. Not so easy on a live stream. Well, it's easy. It's just a bit boring. Might be able to continue doing a bit more of this. Oh, I've just stabbed myself with a pen. Oops. Just drawing things on my own face. I don't know how much I'm doing later this evening. I think it's probably because they had loads of them available. That's why they've sent them. I don't know if they're going to be going out in the full final kits or anything. I mean, it looks like it, but I'd rather they didn't. I'd rather they sent something that was a little bit more deliberate, if you see what I mean. Considering it's one of those features that people kind of, I think, look forward to or change to Klipper 4 at the moment still. It would be nice to see it implemented in a little more tidy way. I quite like the fact that they've got the plug at the back and it's deliberately temporary. That's good. And maybe because it's kind of temporary, they were like, oh, we don't need to worry about it too much. But it would be nice if it was like a tidier little module with specific places where it would screw in. It looks like they designed the whole printer, then, oh shit, we need to add ADXL. How do we do that? In fairness, it's not core to the fundamental functioning of the printer, so it'll work perfectly fine. You're not going to have problems because it's a slightly different shape. It just seems weird considering they've obviously spent a lot of money on development. There's loads of like injection molded parts and stuff. All those things are really expensive. PCBs are really not. So yeah, might have been nice to have a more deliberately designed one. Or even embedded. I mean, there's a... Yeah, maybe not embedded. Forget I said that. That was a bad idea. But some specific screw places, maybe not on the front, but like something on the side that maybe just matches those two holes and matches two holes at the back. It's just mounting something with one hole, not really a great solution in my opinion. Overall though, I must say, although they did provide this printer for me to do the videos, I think this is going pretty good. Especially for like, what, £350-ish? It's looking reasonably good. And I think we've just succeeded 28K 10 iterations. That is epic. So let's squeeze this down again. So this is going to go max acceleration. So input shaping is going to be 3.1K. Oh dear. So we're going to use, when we do our slicer settings, we'll stick the accelerations that we want to match up to our input shaper quality for external perimeters. So for external perimeters acceleration, we want somewhere in the region of 3K. That will give us the very best quality. And then when we're doing the infill or maybe just inner perimeters, anything that's basically not going to be seen at the end of the print or not affect the overall print quality, we stick that up to the near-ish or much closer to the maximum acceleration, so we can go full send, maximum plastic, just blob it all in there when we're not going to see it afterwards. But we need to set our maximums appropriately so we can reach those things. So we go back to printer and it's in here. Do Control F for printer. So we did max velocity there. Max acceleration. For input shaper, we're going to keep it at 3.1K. But for the actual maximum, we're going to do 28K. I think if you did more iterations, you'd probably find 28 might be too much, but I'm going to stick it on 28 for now. Just give myself a comment note in there to remind me if I forget at some point, which is pretty likely. Maximum velocity, we also need to do we have like 5 minutes. Maybe we'll speed's going to take a little bit longer, or is it quicker? I forget. Use the acceleration graphing calculator to find the theoretical maximum speed. There's only a theoretical maximum. I will explain more in the next step. For example, a 300mm printer with a max acceleration of 3,500. Hence the distance 260, the desired speed. So this is the Prusa calculator. Desired speed, 300. Acceleration, so 28k. I think this is like 220. So this is our, we can get to maximum very, very quickly. This time increasing speeds rather than acceleration. Keep in mind that you can only go up to theoretical maximum value you found in the previous step. In most cases this is very high and a non-issue. In some cases, however, you may be wondering why you can achieve seemingly infinite speeds. This probably means that your printer is not actually able to reach the requested speed at that acceleration or distance. So we can try. Did I do a restart? Hopefully. Oh, it looks like I might not have done. Let's just put. I mean, it's not going to reach it at 28k, but let's try maybe. This is basically going to be a demo because I don't have long to do the whole thing now. We'll do this maybe start of next stream, which might be tonight, but there's probably unlikely. If it is tonight, it will be a little bit unannounced. So if you want to be there, you probably want to, like, I don't know, subscribe or keep an eye on the channel or something. Oh, don't forget, if you fancy one, get yourself a vertical linear motion press. Kits are available in the shop, vector3d.co.uk, as well as Daybreak LEDs, a bunch of white and RGB lighting for your 3D printer. Well, actually, probably really for anything, but they're designed for 3D printers. Cool, this is going maxi chat, isn't it? So it's basically the same procedure as before, but we would increase speeds for different accelerations. But I think that's probably skipped already because we went pretty generous with the acceleration. Yeah, that's skipped. So that would be an example of something that is too high. So there's a playoff with stepper motors. Their torque, which basically relates to the amount of force they apply and therefore how fast you can accelerate, is dependent on the rotation speed. So as speed increases, the torque decreases. So the faster you try and go, the less acceleration you can have. So you want to try and play with them a bit to see which is your optimum position. Anyway, I think that's going to be it for today. An hour and a half, I think that's about what I promised at the start. So I'm just going to try this quick setting. So anyone that you don't have to stick around now, 3D printer stuff is done for today. We'll check back, well, maybe later today or in the next live stream with that. I'm just going to try this stream test so my whole thing will like cut out and stuff. Let me know if you have any questions. Don't forget to subscribe. You can support the channel via like Patreon or buying things from the shop or super chats, but it's probably a bit late for super chats and stuff now. And apart from that, happy printing. Go do some calibration, install some upgrades, have some fun, print some things, and enjoy yourself. So let's try this, ending the stream and see what breaks. Oh, I'm just aware that I'm 30 seconds ahead, so I'm going to wait 30 seconds to let you know what's happening. There we go.